Hello. Today we're going to do a physics question and it's on special relativity. So a spaceship with artificial gravity travels past the Earth with a velocity of 120 million meters per second. An observer on the Earth sees that the spaceship fires its rockets for 2 seconds. Determine how long this event takes in the reference frame of the spaceship. Okay, for me, immediately I write down the variables that are present. So v is the velocity of the spaceship with respect to Earth. So that's very important. So an observer on the Earth sees that the spaceship fires its rockets for two seconds. So the rockets are in the same reference frame as the spaceship. And so an observer on Earth sees or observes the rockets for a specific amount of time. And that should mean that this is not the proper time. So because if the observer on the spaceship measured the rockets, then it would be the proper time because they're in the same reference frame, but this is not. So this is simply just, we have the time and yeah, okay, we're asked to obtain the proper time, the length of, or how long this event takes in the reference frame of the spaceship. So from a person in the spaceship's reference frame. Okay. So let's see what formulas are applicable here. This one is. So T equals gamma proper time. And gamma, we're shown here, is this. So we want the proper time. So first we rearrange it. So it's T divided by that. And this thing here, that's the Lorentz factor. And we use it for velocities that are close, or reference frames that are relatively close to the speed of light. So yeah, if this was like 12 meters per second, then it would have virtually zero difference if from both reference frames. So the answer would essentially be 2 seconds, because from here, this is the Galilean one, but obviously this is not 12 meters per second. So we use the Lorentz factor. Okay. So yeah, this would be time times so the Lorentz factor is this, but since it's the inverse, we can just inverse this again, which is just going to be the square root of 1 minus v squared minus c squared, because we have v and we know what c is, so this works out. Okay, now it's just simply subbing in the values. So we observed 2 seconds. 1 minus. Okay, to make it more simpler, we should convert this to something c. So what is this? 1.2 times 10 to the 8. Okay, and we know the speed of light is 3 times 10 to the 8th. And if we want it to in c, we just do this, essentially. Yeah. And what is this? Okay. So this is just 0.4 c. Okay. So this makes this part more simple, more easy. So it's just 0.4 c. So it's 0.4 squared, c squared, over c squared. And this is 2 times the square root of, the c's cancel out. 1 minus 0.4 squared. Okay, and now we just sub this in, or put it on the calculator. 2 square root 1 minus 0.4 squared. 1.8, how many significant figures? 2. Okay, so it's just this. 1.8 seconds, and this feels like a correct answer because we know that proper time is always smaller than any other observed time from any other reference frames. So yeah, I'm pretty confident that this is the right final answer. So yeah, thank you.